Dan Geer, Senior Fellow at In-Q-tel, and Andrew Burt, co-founder and managing partner at a new law firm called BNH.ai. Welcome both to the Data Exchange podcast.
Thank you.
Yeah, thank you so much for having me. It's great to be back, especially with Dan.
All right. This episode, we're going to talk a lot about AI and machine learning. And in the age of AI and machine learning, what are the security and privacy implications? But before we do so, maybe let's just set aside AI and machine learning. And I just want to get a sense from the two of you. When it comes to privacy and security, what should we be worried about right now? So set aside AI and ML. Just more broadly speaking, what are the things that worry the two of you the most at the moment?
Well, from a privacy point of view, it's hard to, I think, really have an intuitive and at the same time correct feel for how much data fusion accomplishes. You put this piece of data with that, with another, and pretty soon there's no hiding, so to speak. A game I have actually played on stage twice was to pick a member of the audience and begin asking 20 questions. That's that game, 20 questions. But the questions, each of them were, not terrible, but they were sort of vaguely revealing, like in your chest of drawers at home, or do you have any packages of unopened underwear? Things like that. And nobody gets to 20 before they object. Because the point is, you start combining all these seeming non sequiturs and you get a kind of a biographical picture that is beyond what most people would want to do. So I guess in terms of what you asked, for me, the thing to think about is, what is the power of putting data together?
I would also just add to that, and I think that's exactly right. A few years ago, Dan and I actually wrote an op-ed for the New York Times called "The End of Privacy." At least I think that was the title. And I think the key takeaway is that privacy, as we think about it, privacy as it's been discussed in courts and in law school classrooms, and kind of as it's been thought about in the minds of consumers, that is gone. That is dead. This is, in some sense, I think, kind of a war that we've just been losing over the decades. And I think that now is really the time to rethink about what exactly it is that we're fighting for, like what we are trying to protect. And I think Dan can correct me if I'm wrong, but because we've written about this together, I think both of us think kind of recommend that rather than thinking about kind of the game of privacy, it is now something much broader, which I think is best described as data protection itself. And so the question is, how can we protect our data writ large, and how can we protect our data from inferences that we are not comfortable with third parties making, and inferences that we might not even know or suspect are available, kind of just like in the 20 questions game he alluded to.
No, it's interesting what Dan said about data fusion, because for a couple of reasons. One is that a lot of companies obviously are focused on data anonymization, right? So and protections along these lines. But the other things that is hot right now in enterprise IT, and I don't know if you guys have heard of this term, CDP, Customer Data Platform, which is basically let's get data from all sorts of different sources to get a 360-degree view of the customer. And so that's something that a lot of companies are striving to build right now. this customer data platform. But then on the other hand, you have these privacy regulations, which just basically say, as long as you can account for this individual piece of data and you can scrub it when the customer asks for it to be scrubbed, you're fine. But it's interesting. So Dan, what do you think about this customer data platform rush that companies are seemingly headed towards?
Well, I hadn't heard the term, but that's hardly surprising. In a sense, the question is, if suppose that you didn't want to play ball with such a thing, that you knew that you knew that such things existed, and you knew that they were likely to be powerful and so forth, and you just didn't want to play ball, how withdrawn do you have to be? How much do you have to live in a treehouse or in a cave or whatever? How far back well, if you want to think of it that way, how far back in time? Do you have to go back to living a la the 17th century, or you have to go back to living a la the 15th century to not end up in such a database, such a data thing as you're describing? The degree to which that's a silly question, I admit it's a silly question. On the other hand, if one way I measure things is, if you don't want to be involved, what is the cost? What is the cost of not being involved? I mean, my electric company, which is a cooperative actually, they use so-called smart meters. You can opt out of that. It's from someone in my late stage of life and so forth, relatively cheap to opt out. It's $25 a month to opt out, and then you get an old-fashioned meter that can't be queried remotely and doesn't record a pattern of use and so forth. My guess is that almost everybody around here has that meter. In fact, if everybody but me has one, then you can, of course, the number of degrees of freedom there is such that if everybody has one but me, I don't need to have one. They still know everything because they can subtract the sum of all the others from the total. That kind of thing, well, all right, that's $25. You want to make a contribution to a charity, and you don't want them to know who it's from, because your sense of the word charity includes the idea that it's not about who's giving the money, it's about making the money gift. Well, that's fine. You can go to the post office, you can buy a money order with cash. There's a cost to that. It's not dramatic, but there's a cost to that. Whereas if you use a check, or even more so a credit card, that's a record. I wonder if, in fact, the thing that the topic of discussion might be not so much the right to be forgotten, but the right to be unobserved. And what does it take to do that?
Yeah, especially Andrew, as Dan suggests, if you do opt out, there are going to be implications even with your credit score, probably.
Yeah, I mean, so as I'm hearing Dan talk, I'm thinking not just about rights, but I'm thinking about costs and transaction costs, and what is reasonable to ask. And I think, in theory, and I think it's why Dan was saying some of these questions are kind of silly in some sense, because right now much of that is no longer practical. To have to engage in that type of transaction cost every time you do anything that creates the type of data that might end up in one of these databases is just no longer practical. And for almost everyone, it's just impossible. Maybe for kind of select decisions, you can do it. But just across the board, the scope and the breadth of the data that's being collected on us is frankly unimaginable. And so I think what we're seeing from a legal standpoint is we're seeing laws try to kind of claw some of these rights back, and they're trying to, I think, reduce the transaction costs. I think a big headline is last week. I don't know when this will air, but we're recording this on the heels of the passage of the California Privacy Rights Act, which is basically CCPA 2.0. So they're adding new kind of provisions to CCPA. But we still just have a ways to go, and frankly, it feels like we're drowning in a sea of data. So just to kind of, I don't know, clarify, I don't think anyone has given up, and I think regulators are certainly increasing the compliance burden on data, specifically increasing the compliance burden on AI. But it feels like we have a lot of work left to do to get to a place where life is really reasonable if you want to, if you're serious about protecting your data, either as a consumer or as an organization.
Oh, Andrew and Ben, I'm coming from the direction that a thoroughgoing AI can draw conclusions that I can't draw, that it can discover facts or interrelationships that are not even known to me. I mean, I guess it's sort of carrying it too far, but can the machine know me better than I know myself? Well, that's an interesting question and perhaps only a philosophic interest, but I think as a conservative assumption, that would be the case. So what if somebody knows something about you that you don't even know about yourself? These days, that might well be someone did a sequenced your DNA without telling you. All right. Where does that go? Is that equivalent to what a thoroughgoing, a general artificial intelligence? Is that equivalent to? Is someone sequencing your genome equivalent to a general artificial intelligence having access to all the records of you?
Yeah, no, it's interesting. By the way, since you folks started talking about AI, I was talking to a security person a few weeks ago, and he pointed out to me that, look, the internet has been around for a long time, and we're still haven't actually gotten our arms around securing the internet in some ways. And now we have this ML and AI, and obviously that's still very early stages of grappling with security related issues and questions. So are there specific lessons, Dan, from cybersecurity that the people in ML might learn from, given that they're just getting started thinking about security?
Well, we've learned. The question is how to generalize things we've learned. One of the things we've learned in the cyber arena is that you can't make the opponents go away, but you can send them down the street. I can't keep you from stealing my car if you're really serious, and you have everything up to a heavy lift helicopter and a Marine battalion. You're going to get my car, but I sure as hell can make my next door neighbor's car more attractive than mine. And a sense that I win if someone else is a easier target is not particularly satisfying in the sense of the word win, but it is nevertheless true. And we've learned that. And we do that all over the place in terms of, well, how can you prevent this? And the answer is you raise the cost to the attacker to the point where it's no longer advantageous to the attacker to do to you what you don't want done. So that's one thing we've learned. And I think that there's probably something for the AI community in that, but I don't know quite what it is. How do you raise the cost to the opponent? I mean, I think that's playing out right now in the deep fake arena, where the adversarial generative networks are, can I make a deep fake can this AI make a deep fake that AI can't figure out? I don't know whether this idea of that we learn in cybersecurity. I mean, I don't know whether the idea of raising the opponent's cost is going to work out well in AI, but there's one example. Another thing in cybersecurity is for certain subclasses of problems, like, for example, crypto problems, we have something that closely approximates ground truth and that there is mathematics behind it. And if you start with mathematics, you can, generally speaking, take some things as axioms, and we can agree that some things are axioms, and you can work forward from that. This is an NP hard problem. Therefore, we can make, well, going back to the question of work, we can, if this is an NP hard problem, then the following sets of mathematical equations can't be solved by an opponent with finite computing. Well, we understand that. And so what is the equivalent set of axioms, if you will, that we can accept as ground truth for AI, just as we've come to have some in the crypto world, because we were able in the crypto world to go in the direction of mathematics. And furthermore, the mathematics, in a wonderful sense, allows us to estimate the cost or level of effort or probability, or pick another word along along that line, of what it would take someone to defeat. The whole effort going on today in so-called post-quantum cryptography has that idea. It's well, suppose someone has a quantum computer. How could we do this? And we're making progress on that. But that's where there's a ground truth. What is the equivalent? What is the correlate in the AI world of the ground truth that mathematics provides us in terms of cryptography? I don't know what it would be.
So that's the challenge right now in machine learning and AI, because it's still in a highly empirical age. So there's not a lot. There's probably less axioms and theorems and more around empirical results. Which, by the way, a lot of the empirical results are getting to the point where they're computationally expensive. So there's not a lot. So the number of experiments you can run is by definition limited, because they cost millions of dollars to do one run of training.
Yep.
So the amount of exploration is probably limited by the current approaches we have.
Another thing that I think we've learned in the cybersecurity arena is that the most important engineering goal is not no failures, but no silent failures. And that is a very much a security-centric view, is not that you can absolutely prevent failures, but you can ensure that the failures are noticed. There have been many examples where, including all the way up into classified areas in government, where something is discovered and the very first question that the general counsel asks is, how long has this been going on? It isn't so much, did we have a break? It's, how long has this been going on? Because only if you know that can you bound the scope of what is now the problem, at least of mitigation. But how long has this been going on? And that can only be answered if you have the kind of security design that anticipates having to respond to such a question. And again, I think that's something we've learned.
I would also just jump in. Sorry, Dan, did I cut you off?
No, go ahead. Please.
Okay, so just, I think failures is one of my favorite topics, just in general, in cybersecurity and in AI. And I think there are very few areas where the world of AI seems so young than when discussing failures and when planning for failures. It's something we see companies at BNH all the time just have a very hard time planning for. And the idea that you are not doing responsible AI seriously unless you're planning for failure, unless you are admitting that the models are going to fail and asking concrete questions like, what do you do when there's a model failure? What do you define as an incident or a failure? It frequently ends up being a business decision whether or not you actually take down the model. So like, what are your processes involved in that? How do you think about legal privilege? There are all of these questions that are just very practical And in the traditional cybersecurity world and traditional cybersecurity incident response, there's frankly like playbooks for this, but in AI, for whatever reason, there aren't. And these questions are very hard and very surprising. And so understanding and accepting that failures will occur is like, I think just a central part of being mature about risk and cybersecurity. And so I think Dan's exactly right.
And in cyber, it seems like there's a lot there's a lot of tradition and processes around uh, what you call it, understanding the cause of failure, right? So they have tools for drilling down into incidents and things like this. So I think AI, these tools are still in the very early stages of getting built. But then also in AI, you have the extra challenge of you now have two pieces, right? So you have code, but you also have data,
Right.
because the AI depends on data.
I would say that one of the big, what should we call it here, a paradigm change, a sea change, is as we move toward ever more data and data-driven algorithms, we don't really have what, as a computer person, I would call source code. We have source data. And I think that more or less proves a point that, this sounds self-serving, but I'll say a point that I've made a while now, and that is in the world of AI, it is data integrity, not data confidentiality, that holds the first amongst equals positions for what are you worried about. Data integrity is far harder, I think, to police than data confidentiality. Data confidentiality is almost a binary setting. You know, is the door open? Is the door shut? Is the data here or is it there? You know, that's versus data integrity. There was a book I read that I can sort of recommend. It's about the art world. The title is Provenance, and it has to do with someone who managed to insert pictures of paintings that he had made that were fake by famous modern artists and the like into the known catalog of the works of various artists. And by getting it into the catalog, as opposed to stealing something from the catalog or stealing something from a museum or stealing something from a gallery, he got these paintings made and then inserted photographs of them into the canonical record of work of these artists, thereby making what he had in his pocket, so to speak, in his back room valuable, not because he had gone and taken it, but because he had put data into in this case, the equivalent of ground truth for modern art. That, or the deep fake example is another one. What do we do when we have data integrity as our top goal rather than data confidentiality? And I think the AI folks might want to consider that as their problem and not the confidentiality one, the privacy one that we were talking about a minute ago, but more the integrity one. What does it mean to have data integrity when there are 10 to the 7th sensors feeding your CDP? You know, what does that mean?
Yeah. Andrew, data integrity.
Yeah, so as Dan is talking, I'm actually pulling up Provenance and buying it because I think that point is exactly right, and that would be a poisoning attack or some form of a poisoning attack in the AI ML world. As he's talking, what I am thinking is basically, so in the traditional cybersecurity world, we have what he's talking about, which is called the CIA triad for confidentiality, integrity, and availability, and these are like the central tenets. And confidentiality has always been kind of the more prized, or as Dan said, first among equals. Now that's moving to integrity, but as a lawyer, sitting here thinking about this, and someone who is, running a law firm involved in all of this, it just highlights to me how traditional legal concepts like privacy or reasonable security standards no longer clearly apply. They are all just kind of blending. Like what if integrity is what is central to protecting a model, what does privacy mean? How do we translate notice and consent and purpose limitations and all of these traditional things from the world of privacy? How do we translate that into protecting the integrity of models? And the same thing would go with security standards, which are heavily, legislated and regulated. So I think it's right, and we've written about this, and integrity becoming central. From my perspective, I think it raises even more questions, which is just, what does this mean from a legal and a liability perspective? And I think there are kind of two answers. One answer is it means we have work to do. Like, the laws don't adequately match where the technology is, and everyone, policymakers and regulators on the one hand, and then also like companies on the other, we need to figure out, how to make sure the laws are right and companies aren't liable. On the other hand, I also think there's just a lot that's unclear. I don't know what the right answers are. Dan, I don't know if you have policies kind of pre-written in your head, but like, what's the right way that laws can ensure that, AI practitioners are properly protecting the integrity of the data? So much of the data. Yeah. Anyway, I could go on, but I'd love to know what you think.
Andrew, do you think that what I know, the word I know to use, which I stole from your field, is interrogable? Do you think that algorithms have to be interrogable?
I love that, and I love the I've heard you say it before, Dan, interrogatability, which is a hard and fun word to say. I don't know. I mean, so I think so. It depends on what we mean by interrogatable. If we mean by, can you interrogate them in a way that is easily understandable to the average consumer, I think the answer is no. I think that's just impossible and unreasonable. Actually, CPRA that was passed recently and GDPR all have provisions on this. They say you need to have meaningful information about the logic involved. And so it's not yet exactly clear what that means.
Well, the reason I ask that is you can't challenge a decision if it can't explain how it made it. Is that correct?
Yeah. So the question is, do you have to understand the whole decision, or do you only have to understand parts of it? And so there are things like Lime, for example, which is like a surrogate model that, and Ben can correct me if I'm wrong here, but that will sit on top of the actual model and basically loosely explain what's going on. And that can be very helpful. But the idea that we're going to get like a deep neural network, we're going to be able to fully explain it in a way that's meaningful and comprehensive to consumers, I think I just don't know if that's realistic.
Or it might, I think people are working on it, but which actually this discussion brings up another thing I've been thinking about, Dan and Andrew, in the following context, right? So before, when you talk about security, okay, so I have the Windows source code. I accidentally publish it online, right? Or someone stole it. So then my IP is gone. But now in this world, you have these two notions: model extraction and model replication, right? So what if so you read a lot about these companies hiring these expensive machine learning engineers, paying them NFL level salaries, right? So but what if I can, with a few hundred queries, interrogate a model and replicate it? And so this company that just spent millions of dollars building that model, now I have a model that's kind of similar to their model. So how do you secure against that?
It's interesting. I was trained as a statistician, for what that's worth. And I'm old, so I'm now talking about some, things quite several decades ago, actually. And when statistical analysis systems that ran on mainframes first showed up, none of them would tell you how their code worked, which is, we'll use the word algorithm because that's the new word. nobody would say how their code worked. But one of the people that I was with at the time set out to show how the computations for all of the standard statistical tests, and some exotic ones too, how they were done by crafting carefully designed data sets and asking the statistical analysis system to derive the statistics that were of interest here. And you could, by feeding it carefully constructed data sets, determine how their algorithm worked. Do you take the sum of the squares? Do you take the square of the sum? Do you, and so forth and so forth. Many of these calculations have ways to speed them up. Do they have these speed ups? And some of the speed ups have, and this is the point I'm getting to, some of these speed ups are not numerically stable. And so the question of numeric stability was something that was thought to be, for those who were going into statistical computing, a core skill, the assessment of numerical stability. Now, the question is, is that a metaphor for what we have now? Do we want, and Andrew, maybe this is back to you, but do we need some sense of the algorithmic equivalent of numerical stability? This particular calculation, this particular neural net formula, this particular kind of optimization, it can be fooled by the following trick. Do we have those kinds of tests? There's so much being done in cybersecurity for trying to analyze source code, looking for patterns of vulnerabilities that are undiscovered. And we're discovering vulnerabilities at a mighty fast clip. Is there a parallel to numerical stability in the AI world?
Yeah, I mean, so when you're saying that, I'm thinking, what even is a vulnerability? In the world of AI, is it clear what vulnerabilities are? And I think, to Ben's question of like, what do we make of model extraction attacks? What do we make of this ability for models to just be, frankly, pretty easily stolen and extracted? And I think it's just it's not as clear as it needs to be, which is bad news, because we're it feels like it's already too late. We're so, I mean, even though that we're new to this world, so many billions of dollars have been thrown at this problem. There are companies that all they do is AI. And for us to be sitting here saying, what is an AI vulnerability in the real world, feels kind of crazy, frankly. On the other hand, and I know this because I'm involved in doing this, there are lots of concrete things that can be done. And they're not actually, they're nowhere near as hard as training and deploying a model. We just have to get data scientists and lawyers and legal risk personnel to actually do them. So there are a host of concrete things that can be done, just like applying basic access control to models, and thinking about like bandwidth throttling for their APIs if it looks like a model attack, extraction attack is in fact occurring, which again is not rocket science. And so I think really the first thing we need to get AI practitioners to do is just think about what the vulnerabilities and the liabilities are, and then even just loosely try to mitigate them and to minimize them. And so we're not going to solve this problem. The problem hasn't been solved in traditional cybersecurity, but I think we can really kind of minimize the vulnerabilities or minimize the attack surface just by doing some basic things.
Yeah, for things that are really serious, like sending a small computer to Mars or something, we have some idea about certification. We have an idea about how to test something and test it some more. And in some circumstances, we have that here on Earth, like, for example, the algorithms that control radiation exposure in a CAT scan, for example. So there's one strategy for cybersecurity which involves very difficult, I'll use the word hostile in a sense that I hope is understandable, hostile testing followed by certification, followed by brutal change control. We have certified this, we're not going to change it. On the other hand, there is something called moving target defense, which is if I assume that my opponent has a minimum amount of time before they can reverse engineer my product and attack it, then as long as I change my product more often than their minimum amount of time it takes them to reverse engineer it and create an attack, it doesn't matter if I have vulnerabilities because they don't last long enough to be utilized. So those are the two extremes, if you will, of what we know how to do. One is radical simplicity and certification, and then no, we're not going to change that. And the other is we're going to change it so often that the opponent can't keep up. I don't know if those ring any bells in the AI world, but that's one aspect of the cybersecurity protection game.
Yeah, I guess to the extent that maybe in the AI world, if you are constantly retraining, refining, and tuning your model, but those might be incremental changes, maybe not to the level of change that's required by what Dan is describing. But by the way, another thing that I wanted to pick your guys' brain on is the balance between transparency and security, right? So take an algorithm that people know about, right? So like Google's page ranking. If they publish in detail how that works, then obviously everyone is going to game that algorithm, right? So same thing with Facebook. So I don't know if this is something that comes up in cyber, but transparency is an issue in AI and ML because people want some level of transparency. But on the other hand, is there a trade-off between transparency and security?
I'll just I think we could both talk about this for a very long time. I write something regular for HBR, and I wrote a piece I think at the end of last year called "The Transparency Paradox," focused just on this in AI. And I think the answer is certainly the more you know about any particular model, the more you can take advantage of it. And so this is not a satisfying answer. It's a balance, and that balance needs to be made against the risks. There are anyway. I will leave it at that. I'll let Dan.
No, I don't have much. I don't have much to add, Andrew. My guess is that we could learn something if we had in this conversation someone from the high-speed financial transactions world, where the business of putting out a bid, putting out an offer, and then retracting it quickly and so forth is all intended to figure out what your opponent, in this case, other investors, to figure out what their strategy is and game it. The high-speed financial trading is exactly that.
There's a lot of kind of phantom trades, right?
Mm-hmm.
Yeah. Where they go unfilled, they're just probing the system.
They're just probing, right. There were a couple of brokers, and this is 5 years ago now. There were a couple of brokers in New York who were small guys. They weren't a big firm, and they suggested that the SEC should require that any bid or offer made on an electronic exchange should be valid for, if I remember right, 50 milliseconds. And there was a huge pushback against that would upset what we were just talking about. All right, 50 milliseconds. There's no human being that can react to that. It's quite fascinating to say we're going to that a strategy for controlling risk would be a rate limiter. It's just fascinating, I think.
By the way, another thing that I should get your guys to weigh in on is so when we talk a lot about security, cyber, or even ML security, we talk about maybe servers or even edge devices, right? So, but I have friends who are working on a new area called tiny ML. So this is ML in microcontroller. So, few watts appliances and things like this. So, potentially ML in places where it's hard to update the model. So once you can break into the model, who knows when it's going to be
Oh,
updated again,
absolutely.
right?
That is a big question and has been for some time. Should or should not an embedded system, meaning something that's inside an automobile or whatever, should an embedded system have a remote management interface? Should it be possible to update it? There's an argument for and against. And frankly, if we want to do this as a debate, you can pick which side you want to take, and I'll take the other side because both have good arguments. The argument for management interface is, what if you discover something terrible? You have to be able to fix it. The argument against it is any management interface represents a potential vulnerability, and the competent opponent will not only find that vulnerability, but will use it to then prevent you from doing the updates that you thought you were doing, which goes back to, for example, Stuxnet. So does an embedded system need a remote management interface or not? And that's a debating question more than anything else, but you can take either side and make a great case.
Or Dan, just generally, there will be situations where you will deploy ML in one of these microcontrollers that's not connected at all to the
Right,
internet.
right. Oh,
For what it's worth, I would just
go ahead.
Sorry, go for it, Dan.
Go ahead, Andrew. Sorry.
Oh, for what it's worth, I would just make the point. So I think that's totally fair that this is a debate. But I would say I am very, very strongly for the idea that embedded systems need to be able to be updated. And one of the things, as we're talking about this, that stands out is, I think in traditional cybersecurity, where you're thinking about adversaries, that is true. But I think machine learning and AI is fragile in a way that traditional software code is not. And so the idea of being able to deploy a model, which for all sorts of reasons can fail, and incidents can occur that have nothing to do with adversaries, just like model drift itself can be a huge problem over time. There's a wonderful paper called, I think it's by Google researchers, are called Machine Learning, the High Interest Tech Debt, or the High Interest Credit Card of Tech Debt. And so for me, when we think about AI, it feels very clear that deploying any model without being able to update it just seems like a recipe for disaster. So I guess I would venture to say that I think Dan is exactly right, but I think in the AI space, in my view, I think it's more clear why we want to be able to update models. But Dan, you can correct me.
No, I agree with you. I think the key point you were making was that they're fragile enough that that changes the trade-off, and I would actually agree with that. I think it changes it in the direction of, you got to be at least able to send a reset, if nothing else.
So it seems like at this point, so I'm kind of oversimplifying here, but the way machine learning and AI is evolving is a lot of the innovation and talent will be concentrated in a few companies. In basically, again, I don't want to offend our European listeners here, but basically concentrated in China and the US, right? Because it seems like there's some ingredients you need to have in place. You have to have data, access to compute, those two, and then to some extent, honestly, even a hardware ecosystem, because compute depends on a lot on hardware. So it's not quite monoculture, but it's we're getting to the point where a lot of the field is concentrated in a few places. So I don't get the impression that's the case in internet technology or cybersecurity. So is this a specific challenge to this field?
It's probably more prone to concentration in what you're talking about. Yeah.
I would just say, so I feel like anytime anyone says monoculture, it's like we need to just listen to what Dan has to say. So Dan, I don't know if you want to if you want to add anything to that. I would say something. This is a quote that comes from me. It's going to be in a white paper published next month, but that I just think about all the time, which is that software is the exercise of power over space and time. And when you think about software as the exercise of power through language, for me, that has helped me kind of see what's going on as we digitize more and more of our world. And AI in particular, I think, is an even more concentrated way of exerting that power, of doing lots of the things that traditional software systems do. And for example, just to get a little more concrete, we're working on one particular incident at the law firm where a group of data scientists made a model, deployed it, and it affected hundreds of millions of people around the world. I think the team is 5 data scientists. And so the idea, like even the idea is almost inconceivable that 5 data scientists can train a model, deploy it, that can reach out and touch hundreds of millions of people in a relatively small period of time, I think is unique to AI. So what I am expecting and what I think is happening is just the world of AI is even more concentrated than the world of software. And so it makes a lot of sense to me that we're going to have, only a handful of pockets that have the expertise and all of the different ingredients that go into, being able to, make and deploy, high quality AI.
Yeah, because it seems like there's, I don't know if you guys are familiar with the diagram from Andrew Ng, the AI flywheel, right? So you have a better product, which gives you more users, which gives you more data, and then gives you a better product. So it's just kind of someone who gets more users, gets more data, gets a better product, and it's just kind of hard to dislodge a player like Google in this case for search, right? So
indeed, barriers to entry is a topic that I don't think we have a good handle on in this space yet. What is a barrier to entry? Is it a bright idea? Is it years of data that you got from other people for free? What is it? What are the barriers to entry?
Right. Compute is definitely becoming a barrier to entry as well. Training these models that have billions and billions of parameters.
Particularly if there's no way to ask it why it does what it does.
And
it
just works, Dan. That's the criteria.
Well, we will see that. There was actually an article in Technology Review, is it a year and a half ago? It might even be 2.5 years ago, in which it basically made this direct statement that nobody will care how medical AI works as long as it's better.
That might be an exception.
It might be.
Medical AI. Yeah.
If the diagnoses are more useful, well, nobody will care how it made them because they're more useful, and that's close to the heart, so to speak.
So Andrew and Dan, so is AI in particular, I guess this is true even in cyber, right? So you might have the best AI system, as Dan describes. It makes one mistake. That one mistake generates massive media coverage. Self-driving car, right? It's good. I think everyone kind of thinks that we'll be better off with self-driving cars in the future once they get to a certain point. But maybe one accident could set that effort back.
Andrew, are you familiar with the trolley problem, so-called?
Yes.
Well, that's your cue.
No, that's my cue. Now I have to go describe the trolley problem, Dan. This is it's a philosophical question that, as far as I'm aware, still has no good answer. But basically, the idea is a trolley's coming down, and there are a variety of different outcomes where people could get hit. And so the question is, what do you do? Do you optimize for human life writ large? Do you optimize for specific types of human life? it brings in to forefront this question of, when we're doing something that's high risk, we're creating liabilities, how do we make these concrete decisions about what exactly to do? I have one thought related to the prompt, Ben. But Dan, is that where you were?
Yeah, that's where I was going. You know, you're coming down the road and you're driving the trolley, and you see a crew of workers ahead of you, and you can either plow into them or you can divert onto the side rail and kill one person. Do you kill one person or five? And what is your culpability in making the decision?
Yeah, I think so. So what I would say, let me, I mean, this is the reason why I'm doing what I'm doing. So let me just, I'll hit a note of enthusiasm, maybe muted enthusiasm. But I think we are really at a point where we can prove that the technology works. I mean, obviously AI is the subject of lots of hype, but it is also the subject of hypes because it really can do amazing things. And throughout this whole conversation, I've been using AI and machine learning somewhat synonymously. So forgive me for that. But there are lots of reasons to think that it can legitimately, make our lives better and change our lives. That being said, there are many ways we can screw it up. There are just so many ways. And from my vantage point, sitting as a lawyer and thinking about liabilities, feels like they're innumerable. Like there are so many accidents that could just stop this momentum. And so I think the real question is, are we, as a broader group of technologists, as a community of people who are trying to get society to adopt new technology, are we capable of doing that responsibly? Are we capable of doing that in a way that minimizes harm? And if the answer is yes, then awesome. And if the answer is no, then we might not be able to adopt technologies that can change our lives because of mistakes just kind of like the ones you described.
By the way, here's one reason why we can't be optimistic, because I guess map it back to the internet, Dan, which is basically, who would have thought that when I first saw that you could buy something on the internet by giving them your credit card, I thought that was a terrifying prospect. But now we just do it routinely, right?
Oh yeah, no, becoming inured to risk as a literature on that question of becoming inured to risk, and it, I think, confounds planning at all sorts of levels, and not way beyond the topic of discussion now. You're far more likely to be injured. Well, actually, to make it germane to this, one of the standard arguments, and I think it's probably true, is a self-driving car doesn't have to be perfect. It just has to be better than you are. Except that I don't know, this is a cue to Andrew, I don't know that the legal world will readily adopt such a position.
I mean, there was the fatality caused by Uber's self-driving car in 2018, and there was actually just in the last month or two, they actually charged the driver, the human driver sitting behind that was supposed to be supervising. That driver was charged with, I think, negligent homicide, whereas the Uber engineers settled very quickly, Uber as the company. And as far as I'm aware, there was no further legal action against them. So it's incredibly complicated. And honestly, I think we're entering a world where what it means to be autonomous is going to expand. Drone companies, and I've seen during the pandemic lots of just different types of automated service and delivery systems. So I think the next 3 to 5 years are going to be wild, watching all of these kind of cases work themselves through the courts.
One of the things that by the way drives autonomy, or drives the requirement for autonomy, is data volume. Right. Sensor data going back to headquarters, whatever that means, going to the cloud somewhere, being massaged and then coming back is fine if you have the time for that. And if you don't, you need autonomy. You need it on board. Fighter planes would be the best example of that. They can have more sensors than you could ever possibly get the data down to ground control, into a computer, out again, back to them. They have to have autonomy. because the whole point of the so-called OODA loop, observe, orient, decide, act, that loop, the whole idea of that loop is if you can run your loop, your observation, orientation, decision, and action, if you can run your loop faster than the opponent, you eventually win as an inevitable thing. Well, if speed of processing and decision making is the issue, it's easy to have more data than the bandwidth can support. And so the demand for autonomy, at least in that kind of circumstance, is absolutely irresistible. You know, of course we're going to have autonomous weapons. And the reason is what I just said. Now, on the other hand, that probably doesn't apply to, oh, I don't know, make something silly, an autonomous coffee pot. You know, it doesn't apply to that. But there's a trade-off there somewhere. And the nuance, the finding the bright line to divide one realm of rules from another realm of rules is going to be something that the legal community is going to have to wrestle with. I think, Andrew, I think you're right. 3 to 5 is probably, but that's probably optimistic.
Actually, so let's close with the two of you kind of just give parting shots. So Dan, in your case, I'm curious, to what extent is the security community engaging with the ML and AI community?
I'm not sure I'm competent to answer that beyond the idea that the security community wants to use AI and ML technique to improve the detection of events going on. You know, how do you know if someone who's really good at secreting themselves in a network and exfiltrating data in a way that ordinary security programs won't notice it, and so forth? This idea of using AI and ML to do what's called indicator of compromise, that I think is the point of closest interaction. I don't know.
So is there the reverse direction? Are they helping the AI and ML folks? Is there
AI and ML folks helping the security people detect penetration? Yeah.
Yeah, but what about the security people helping ML people? Is that happening?
Not that I'm aware of.
Yeah, that we need more of that.
Well, I don't know who to tell, but I agree with you. Tell somebody.
Yeah. So Andrew, any parting thoughts?
Yeah, I would just say part of the way, and exactly on the last lines of needing information security folks more involved in machine learning, part of the way that we are going to get this right, part of the way we're going to make AI realistically and like responsibly deployable is by bringing in these other types of expertise, technical, legal, security oriented, because the idea of having, which I think is fairly representative, of having data science and AI be relatively insulated from other areas of organizations and other types of expertise, it just breeds all of these different risks. And that's fine, I think, in an academic environment or in a theoretical environment. But in a world where we're actually building models that are deployed onto delivery vehicles and drones and cars and other things that are actually interacting, directly with consumers and creating harms, that alone is just not going to cut it. And so I think the AI community itself is becoming more aware of this. I think regulators are becoming more aware of this. We'll start to see, I think, new and increasing regulations. But I think unless things change, and unless, frankly, more people get involved in making AI real, I think realistic, I should say, I think the risks are going to go up, and I think the risks might end up being too great for adoption.
And with that, thank you, Andrew and Dan.
Thank you so much.
You bet.